Alright, so in this example we've moved on to the Poisson distribution, which is another discrete probability distribution, another formula that you're given when working with a Poisson distribution. So this is in the formula book, and just as with the binomial distribution, this gives you an exact probability, whereas the tables that we're going to pull off the calculator give us a cumulative probability. So in this example, the number of telephone calls received in an exchange during a weekday morning follows a Poisson distribution with a mean of 6 calls every 5-minute period. So with a Poisson distribution, you tend to be dealing with averages within a fixed period. So the average of 6 gives us the distribution. So if we call the variable x, the random variable x, this would be a Poisson distribution with a mean of 6. So first of all, there is no calls received, so probability x equals 0. So using this, lambda is 6, so we have e to the minus 6 bracket 6 to the power 0 over 0 factorial. Well, anything to the power of 0 is 1, and 0 factorial is also 1, so that's equal to e to the negative 6. If we do that on our calculator, the exponential function is above the natural log, so it's above the ln there. So shift that to get the e to that. When you're putting negative in, it's that button, not subtract. So e to the negative 6, which is 2.47 times 10 to the minus 3, which is 0.0025. So pretty small likelihood. B, probability x equals 3. So this time now it will be e to the negative 6, 6 to the 3 over 3 factorial. So on our calculator, shift e, negative 6, bring it down, open bracket, let's have a fraction in there, 6 cubed on the numerator, 3, and the factorial is above the x to the power of minus 1, the reciprocal. So shift to get that, bring that back up to close the bracket. So you can see there it's written exactly, it's typed in the calculator exactly as we've written it, which is great. So 0.892, 0.0892, probability of exactly 3 calls. C, fewer than 2 calls are received. So if it's fewer, that means it's not less than or equal to, it's less than 2. Well, because we're working with discrete data here, that means probability x equals 0 or probability x equals 1. We've already worked out probability of x equals 0, but I'm doing it this way just to show you that what you've got where you're adding probabilities together is, if you think we've got e to the minus 6, 6 to the 0 over 0 factorial, or e to the minus 6, 6 to the 1 over 1 factorial. If we added another one, you'd still have the e to the minus 6 there, so that becomes a common factor. That is 1, as we established in part A, and this is going to be 6 over 1, which is 6. So that works out to be 7e to the minus 6. 7e to the minus 6. 0.174. Part D, so we haven't used any tables yet. So in this one, probability X is more than, so that is not inclusive. Probability of X being greater than 2 would be the difference between complete probability 1 and X being less than or equal to 2. And this time we'll work that out on our calculator. So the calculator, Poisson distribution, menu, 7, page 2, and we want number 3, cumulative distribution. We want the variable version. We're interested in X as 2 and lambda is 6. So this is going to be 1 minus 0.0620, but I'm going to store that in my X variable. Menu 1 minus X equals, so 0.938. So pretty high chance of getting more than 2 calls.